In a previous video, I demonstrated how to take picture using a device camera. Since these images are stored on the backend, we later retrieve them to display in our client app. However, the loading full-size images for thumbnails is often unnecessary and can negatively impact performance. In this video, I'll show you how I handle this issue in my project using Angular on the front end and Node.js on the backend. Here is my task panel with image thumbnails, and I don't want to load them in full size unless necessary. My approach is to determine the required image size dynamically and pass it as a width parameter in the request URI. Thumbnail sizes can vary depending on the column width. Each thumbnail initially has a spinner placeholder that occupies the full width the image will take once loaded. In my code, I use the placeholder's width to determine the required size for image before loading it. First, I retrieve an instance of the spinner component after the view has been initialized. Set isLoading to true to display the spinner as a placeholder, and initialize resized image URI to null, preventing the image from loading until we determine the required width. I check whether the image URI points to a temporary device store. If not, it means we need to retrieve the image from the API. And in that case, we must calculate its width. Since the spinner element occupies the full space required for the image, we can simply use its current width for the calculations. Don't forget about the device pixel ratio factor in modern high DPI screens. It determines how many physical pixels exist per CSS pixel. For example, if a preloader appears to be 100 px wide, but the device has a DPR of 3, you actually need to load a 300 px wide image for better visual quality. I account for this in my calculations by using the pixel ratio factor from the global window object. The only remaining step is to append the calculated width as a query parameter to the image URI. Once updated, the resized image URI signal property triggers the image loading process automatically. The controller extracts the requested image width from the query parameters. It's essential to enforce a maximum limit. Allowing users to request arbitrarily large images could degrade performance or even expose the system to DDoS attacks. In my case, I restrict the maximum width to 1000 pixels. Once validated, the width is passed to the getImage use case, which handles the image retrieval logic. If a width is specified, the image resize service resizes the image before returning it. The resize service operates on a readable stream, modifying the image on the fly and returning a resized stream, along with the correct content type. In my service, I use the Sharp library for image resizing. Sharp is a high-performance Node.js image processing library, optimized for speed and efficiency. I used prop image size library to preserve the aspect ratio and determine the MIME type before resizing. This library is highly optimized. It only reads as much of the stream as needed to extract metadata. That means there is no need to buffer or load the entire image, making it perfect for large files and streaming data. I conducted some experiments with resizing a large image, 2.6 megabytes into a 20 kilobytes thumbnail on my test server, which is running a single-core, single-thread CPU. I accessed the image directly from the server's file system. No Google Drive or external API involved. When serving the original image, average total load time approximately 2 seconds, and time to first byte from server approximately 200 milliseconds. With resizing applied, server response time increased to approximately 500 milliseconds due to CPU work, but content download time dropped to less than 10 milliseconds. In total, image delivery was about 4x faster. From a user perspective, this is a major improvement. Images load significantly faster, which is especially noticeable on mobile networks or slow connections. The only downside is the image resizing is very CPU intensive. On a production system with many concurrent users, this approach could lead to high server load. An ideal use case for this approach is building application for a restricted number of users, operating in areas with poor mobile network coverage, where user experience relies heavily on fast image loading. Let's return to the Angular client application to take full advantage of progressive web app capabilities. By catching images with Service Worker, we reduce server load, improve user experience with instant image display, and enable offline access. This JSON Service Worker configuration block sets up catching for all images fetched from the specified API endpoint. The presented solution has a drawback from an architectural perspective. It causes the client to overuse server resources by triggering heavy operations on every request. A more efficient approach would be to generate thumbnails of a universal size when the user uploads an image and store them alongside the original. If a thumbnail doesn't meet the required size in a given context, the full-size image can be loaded in the background as needed. If you are interested in this optimized approach, let me know in the comments, and I'll make a video about it. Using the full-size images for thumbnails is inefficient. Resize them to save bandwidth and improve performance. Consider using image placeholders to dynamically detect the required dimensions. Don't forget to account for device pixel ratio when determining image sizes. Restrict with resize parameter to prevent abuse and ensure security. Cache images after the first load to reduce server load and speed up future requests. Keep in mind that image resizing is CPU intensive. Scale carefully, especially in production environments. You can find all the related code at the link below. If you enjoyed this video, don't forget to follow the LSBC YouTube button. Like, subscribe, hit the bell and leave a comment. Your support means a lot for me. Thanks for watching.